Hey everybody. Just want to start off by saying as we navigate through the landscape of history, one thread consistently weaves its way through time. That is cotton. Much like the fibers that intertwine together to make up our fabric, our world is intertwined with uh, the impact and significance of one seemingly simple plant. As you may have heard it, cotton is the fabric of our lives. In fact, all of us here today, we've all been affected by the cotton industry. Like we're all wearing clothes right now. We're all connected to ag one way or another. But the cotton industry is huge. It's worth 25 billion annually. It employs in Texas alone 200,000 Texans each year, with 60% of the cotton grown in the southern high plains of Texas. That's where I'm from, so it's really close to home. But all while this is going on, cotton production over the years has been primarily irrigated. That being said, most of the research done has been over irrigated crops and not as much on the dry land. But due to the rapid decline of the Ogallala aquifer, farmers are being forced to switch production to dry land. So going out into it with little resources could be very dangerous for our society. There are many things that cotton's used for besides clothing, like food is one of them. A lot of the cotton seed is crushed down to make oils for our food, like especially tortilla chips. Another one could be medical supplies. I mean, we like gauze and all kinds of pads and everything. So without it, we could be really hurting. One thing that I wanted to do within my thesis was study the relationships between cotton and climate factors, production factors, as well as fertilizer inputs, just to see how different inputs could affect the outcome. To help farmers minimize their costs, maximize their yields, and maximize their profits. With that being said, though, the preliminary results of my study have not been significant yet, but I believe that is because I have focused mainly on linear relationships. It has become apparent that yield and the other variables that affect it are non-linear. And knowing what I know now, I can better help the farmers minimize their costs, maximize their profits, and maximize their yields, as well as keep cotton consistently weaving its way through time. Thank you.
All right, so as you said, my name is Gavin McIntosh, and I will be modeling left atrial arrhythmias with an interactive in-body simulation. So real quick, by a show of hands, who in this room has or knows someone who has had a heart attack? What about a stroke? All right, well, most likely the cause of either of those things was something along the lines of an arrhythmia. Now, what arrhythmias do is they cause the atrium in your heart and the ventricles to become out of sync. Now, what this can cause is blood clots to form, which can then exit your chamber of your heart and go into your coronary artery, causing a heart attack, or they can exit your heart and go into your brain, causing a stroke. So we have our treatment methods for this. The most common treatment method is catheter ablation. Unfortunately, this is a complex and very tricky procedure to do. So what we wanted to do was make an interactive simulation that doctors could use to test theories and experiment outside of the operating room. So to start out, we have just a strand of cardiac muscles here with a sinus node, and sinus node will put out an electrical signal that travels through the muscles, causing them to contract, and then hold, then relax, as cardiac muscles do. From there, we wanted to move on to our idealized model of the left atrium. We chose the left atrium to model because it's where most arrhythmias originate from. This is because it's the most spatially complex, with the pulmonary vein openings and the mitral valve and the left atrial appendage. So from there, we took our idealized version of the model and we made a couple of textbook reentry cases, as you can see here. First off, we have an area of slowed muscle, so damaged or unhealthy muscle tissue in between these two pulmonary openings. And here we've got an incomplete ablation from a previous procedure. So what happens in both cases is the electrical signal will travel around in a circular motion, causing the atrium to beat way too quickly, which causes the blood clots, as I said before, and in this case as well. So what they'll do is they'll go in and they will ablate a line, so killing the muscle tissue, either like here, here, or here, causing that reentry to cease to exist. And so similarly, we've we've gone on and completed this group ablation here, causing that reentry to stop as well. From there, what every model aspires to be is a patient-specific model, because everyone's heart's different. Some people only have 3 or 2 pulmonary vein openings. So what we can do is we can take in CT data of the heart, build out your spatial model in 3D, and import that into our simulation to be able to recreate patient-specific reentries. And this will keep you guys out of the operating room more times than necessary. Thank you so much. Do you have any questions?
So climate change is a very real threat that threatens millions of people worldwide through processes like rising sea level and land degradation. Unfortunately, climate change mitigation requires everybody to do their part and every sector to do their part and do it really well. Domestically, we don't have a federal system for climate change mitigation, which means that in the United States, we rely really heavily on the voluntary carbon market, which consists significantly of carbon offsetting. Unfortunately, agriculture does not fit well into the offset system, which means that there's a large gap between potential agricultural offset mitigation and realized agricultural offset mitigation, leaving a ton of room for improvement. Even though agriculture is the 4th largest emitting sector in the United States, following only the heavy industries, excuse me, it is the least produced and traded carbon offset on the market. And of those offsets that are traded, it is mostly agricultural land management practices, which is changing agricultural practices to mitigate water usage, to increase soil carbon storage potential, and reduce chemical runoff. This small market share is heavily related to academic concerns surrounding the quality of agricultural land management offset credits. And that credit quality is related to the monitoring, reporting, and verification of the offsets, which can be split into the quantification, which is your hard math, your baselining, your modeling, your measuring, and the qualification of the offset, which is your permanence, your leakage, and your additionality. This MRV is really the backbone of offset policy writing, and it's where we believe the concerns really lie. So in order to study this, we'll be doing a comparative analysis of 2 ALM offset methodologies from 2 of the most traded protocols in the world, one from gold standard and one from the verified carbon standard, which represents a large market share. Once we've identified the issues relating to these 3 questions, is there more room for ALM to offset carbon? Is a ton? Do those credits have high quality? And how do we improve the system? Where inside of the MRV are the issues? We will then propose policy to help close the gap between potential and realized carbon mitigation from ALM offsetting. Thank you.
Let's talk about inflation. That's price increases over time. So for example, housing prices in the US have more than doubled in many US cities over the past 10 years. In 2021 and 2022, we saw inflation rates that were considerably higher than they've been in probably the past 20 years. So COVID really did a number on us. So what this means is maybe a few years ago, you were paying $1,000 a month in rent, whereas now you're paying $1,400 a month in rent. So that's $400 less each month that you have for other things like basic needs, okay? We're not just talking about increases in rent or housing. We're talking about price increases across the board in food, in energy, in everything, right? Prices are up and budgets are strained. So what's interesting about this is researchers have consistently found that a lack of resources is associated with higher crime rates. They've also found when looking at inflation specifically that it's associated with higher rates of crime, particularly property crime. And that's at the national level when looking at the whole of the US and at the city level, looking at specific cities. So What they haven't done is look at specific inflated costs, like costs for housing specifically, or for renters specifically, or food, or specific types of crime, how these inflated costs affect these specific types of crime. And so that's what I did, is look at monthly costs, monthly inflated costs for specific types of inflation for specific crimes in cities. And I found that it's very city specific. So what's problematic in one city isn't problematic in the next. So there isn't a one size fits all solution per se. Rather that local organizations or agencies should focus on what's relevant to their city to alleviate the crime problem by reducing financial burden for people. Potentially reducing. That's all I got.
Mahon. Did you know we can address one of the most pleasant issues plaguing our beaches, seas, and bays using just a polymer? That sounds interesting, right? Yes, that is exactly what this research seeks to do. Plastics, and by extension, microplastics, are a major problem in our marine environment, even on human health. I call them tiny plastics, big problem. Guess what? We have a solution. With fenugreek seed, we can remove microplastics from our water bodies. How do we do this? Fenugreek seed is grinded and soaked in alcohol for 24 hours. And this polymer is extracted from the fenugreek. And through flocculation experiment, we can be able to remove this microplastic from our water bodies. Guess what? This is going to get interesting, because we are not just trying to remove microplastics, we are also trying to mitigate the risk factors associated with one of the major bays in Texas, that is Matagorda Bay. How do we do this? We do this using both risk analysis and machine learning models. So with both risk analysis, we will be able to develop a detailed risk analysis of the risk factors associated with microplastic pollution in the bay. With machine learning models, we'll be able to predict how much polymer we need, how effective the treatment process, that is using fenugreek as a polymer to treat this microplastic pollution in the bay. The brilliance of this solution does not just lie in its efficacy, but it's also sustainable and cost-effective. With this research, we'll be able to restore our marine environment. And also, the beach lovers, some of us like beaches, the beach lovers can be able and would be able to enjoy their beaches even better. I say together, let's make our marine environment better. Thank you.
So just to keep on time, we're going to take a 5-minute break and we're going to start back again at 10 o'clock. Just want to make sure all of our attendees are here. We'll read the name of these 5 minutes.
Okay, show of hands, how many of us have had a pain experience that was so overwhelming we couldn't focus on a task? That happened to a few of us? How many of us have actually experienced the reverse, where we have a task in front of us, and because we have that task, we're actually distracted by our pain experience? A few of us? Yeah. So what that means is that our brain's relationship between pain processing and executing mental functions is actually really complicated, and we don't fully understand how it works. We seem to have this cognitive switch back and forth. So what this study was hoping to address was how acute pain affects our memory functions or our cognitive functions. And we specifically looked at working memory. So working memory is a type of memory that is very attention-based. So you have to hold a piece of information at the front of your mind while you actively complete a task. So what we did is we collected two different groups. We had our pain group and our no pain group. Our pain group received what was called a CPT, or a cold pressor task. We basically put ice cold water on their arm to put them in pain. And then our no pain group, we left them alone. And we put both of these groups through what's called a verbal working memory task. And we really tested their ability to complete a memory task while they're either in pain or not in pain. And while this was happening, we had an EEG on their head and we recorded brain activity the entire time. And so what we found actually was that we had significant difference between our pain and our no pain group. And that our pain group had more brain activity in a very specific region of our brain, where F7, the electrode F7 picks up on. So F7 picks up on a bunch of different brain areas, but what these brain areas all have in common is that they all play a role in pain processing and working memory. So our pain group had more brain activity in this part of our brain. And they also had a specific type of brain activity. So they had what's called gamma frequency. So gamma frequency is the highest frequency that our brain is capable of emitting and is associated with encoding a memory and directing your attention. So when you're really focusing on something and you're trying to absorb that piece of information into your brain is emitting more gamma activity. So we found that our pain group not only had more activity in very specific regions of our brain, but it had more activity, specific type of activity, had more gamma activity. So what this tells us, hopefully, is that someday we can get closer to trying to understand these neurological underpinnings of pain processing and working memory. So we can slowly inch our way to understanding how pain affects our mental functions like memory and attention.
Greetings, everyone. The Western diet is usually one that consists of a very high fat, and it can be high sugar as well. So what a high fat diet does, at least the constant consumption of it, is that it decreases what is known as glucose tolerance. So glucose tolerance is basically how our body takes up glucose after a meal, right? If we have decreased glucose tolerance, what that means is that the glucose stays high in the blood. When the glucose stays high in the blood, that's not good, right? That is a term that's known as hyperglycemia, and it can damage different organs such as the kidney, the pancreas, and the eyes. What the continued consumption of a high-fat diet also does is that it can lead to hypertension. One of the mechanisms by which it can contribute to hypertension is increase in sympathetic neural activity, right? Because your nervous system helps to regulate blood pressure. So what are the current treatments for like diabetes and hypertension? So currently, as you may know, we have different drugs, such as metformin for diabetes, right? We have drugs for hypertension as well. If it gets very severe, there's also what is known as bariatric surgery. Now, these treatment methods, right, sometimes they're not favorable as well as they can be expensive. So scientists have been trying to devise new ways in which we can combat these diseases, right? One brilliant technique is known as intermittent hypoxia conditioning. So basically what that is that we bring down the levels of oxygen from 21% to about 10% in different cycles, right? And that technique has been found to have brilliant effects on different organs, such as the heart and so forth, right? So we wanted to see the effect that this would have on glucose tolerance in a rat, as well as sympathetic activity in a rat. So we fed rats a high-fat diet, right? And then we observed where their glucose tolerance was decreased, right? The rats that were conditioned with intermittent hypoxia, after 5 weeks, we realized that their blood glucose was less, right? The concentration decreased. The rats that were conditioned with intermittent hypoxia, the concentration of blood glucose was higher. Therefore, intermittent hypoxia has proven to actually reduce blood glucose concentration. It could be a viable means of treating diabetic patients, right? It's non-invasive, it's cheaper, right? And it doesn't cause any pain. As it relates to sympathetic activity, in the 5 weeks, we did not see any significant effect of intermittent hypoxia, but science is dynamic, right? Not because you don't see an effect now means that you won't see one later, right? So as a result, we'll keep trying. Thank you.
Good morning, everyone. Over the summer, me and a team put together a monitoring system that we deployed at Eden Green, a vertical farm. It's not too far from here. We had about 12 nodes that we designed that were measuring ambient temperature, humidity, the leaf temperature of the plant, RGB color, light intensity, UV, CO2. We've been collecting the data. We have been updating the design on each of the nodes. We actually have just been over there this weekend to improve upon them. So it's an ongoing process that this was just the first part of a larger initiative to work with a lot of the local farms to create smart monitoring systems. My work on it primarily had more to do with the front-end data collection, the databasing, the network side of things. And though I did help with the building of it as well, we also have other designs that we want to implement in the ag department here that will also do detection of different bugs that are on the roots to determine their growth, the level of growth that we expect to see with them, if they have higher numbers of these insects on them or lower. At the vertical farm, we had hoped to do tip burn detection. However, due to power restraints, we just had these nodes that were all solar pallet powered so that we could just keep them running and out of the company's way, since they were nice enough to partner with us to work there. Here at the ag department, we'll have a bit more control, so we can do some more of the machine learning side of prediction for the health of it that we hope to see. We have just started collecting the data, so it's still in early phases. The main part of this stage was just to get the network up and running. So we have the central node here, and all these smaller nodes are all sending to it via network. So we're testing the network itself to make sure that we can cover across the farm well enough. And so far, we're getting better and better results every time. Like I said, it's an ongoing effort that we have with them, and we hope to see it evolve with other farms in our ag department here as well. Thank you.
All right, well, good morning. So in 2022, in the US Census, 17% of the population was actually age 65 or older. And that's the highest that number has ever been, and it's projected to increase steadily through the year 2050. That being said, I'd like to argue that due to this, aging research is more pertinent now than ever. So if you look at the figure in the top left, it shows the effects of age on muscle mass and strength. So as you can see, early life, we want to maximize our peak, so as much muscle mass and strength as we can possibly get. Adult life, maintain our peak, and then older life, minimize our losses. But as you can see, as our curves get further into the age, we start to drop down into the disability section of our figure. And with disability comes more complications. One of these complications is fall risk. So the reason, or part of the reason, older individuals are such at risk for falls is because they lack type 2 muscle fibers. So these are your fast twitch muscle fibers that you use for like catching yourself. Part of the reason they lack these muscle fibers is due to the de-innervation of these type 2 fibers that happens with age. And this is compounded with the fact that they're just not using them. So in order to combat this, I propose we use BFR training as a preventative measure. So BFR training essentially is similar to a normal training protocol, but the participants will wear a blood flow restricting cuff that restricts blood flow to the targeted area. The benefits or the implication, it has numerous implications for vascular and metabolite processes, but for the process or for the purposes of this, we'll look solely at the neuromuscular. So for BFR, normally to recruit type 2 muscle fibers, you have to have high intensity exercise or highly fatiguing. But with BFR exercise, you're able to fatigue at a lower intensity training and elicit the same effects as high intensity training. So for our protocol, we'll have a pre-post testing that focuses mainly on our randomized isometric tracings. and then a training intervention, and that will be isokinetic leg extension. It'll be 4 weeks, 2 visits per week, and then our 2 groups. The only difference between the groups being that the BFR group will train with the cuff on. So then that brings us to, during the pre-post testing, we'll have an EMG sensor on, and following decomposition, it gives us the motor unit firing behaviors of interest, such as recruitment threshold, mean firing rate, and motor action potential size. So to conclude, this study offers a promising intervention to mitigate loss of type 2 fibers, especially within elderly populations. Thank you.